Welcome to question number 6. Three cables are connected at A, where the forces P and Q are applied as shown. Knowing that Q is equal to 0, okay, find the value of P, for which the tension in the cable AD is 305 newtons. So find the value of P. Let's say Q does not exist, isn't it? Q does not exist, as we have been told it's 0. Now find the value of P, for which the tension in the cable AD is 305. Okay. So indeed, we are duty bound to do some unit vectors in this direction. AC, AB, and AD. We'll do the unit vectors. Why? Because we actually have because of what we've been given. So let's try to solve this one. Okay, and please don't be discouraged. The questions are hard. Follow through, try on your own, and you'll be able to actually get quite good with it. So here we'll first of all try to know, okay, what is Q does not end, so let's neglect it. So P, I see it's in the direction of the x-axis, so the force P is indeed P as a force is equal to Pi, because it's in the direction of the positive x-axis. Okay, and what we know is that at point A there, that is equilibrium of a particle. So when we say when we sum all the forces there, indeed we need to get 0. So we are saying summation of forces at A is equal to 0. Okay, meaning implying that when you sum your TAB plus the vector TAC plus the vector TAD plus P itself, you need to get a 0. Alright, with this in mind, we'll need then to express all these, the TAB, TAC, TAD, we need to express them in Cartesian vector form. Then we'll be able to calculate and get what we actually need. But the question is saying find the value of P for which the tension in the AD is actually 305. Okay, so let's go on with that. We'll first of all begin with the same position vector. I'll get the coordinates for A. So I have A, or let me just go straight with the position vector for A. So position vector for A, RA is equal to, I see I have 960 I, okay, that is in the X, and then in the Y there is a 240, so that's plus 240J, and then in the Z there is nothing. Okay, so RB it's equal to, from what I'm seeing here, and I hope I am correct, there is only in the Z, so it's 380K, and then I know that my RC is equal to minus 320 K, and then I know that my RD is equal to this is, there's a 220 there, and the Z, and then I want to find in the X. It looks like in the X it's 0, so nothing in the X, okay, but in the Y we have something. In the Y we have 960, so 960J plus minus 220K, because it's in there. That's your position vector for so I've gotten for RC, RA, RB, RC, RD. Awesome. Now I need the position vector RAD. Let me start with that one. RAD will be equal to RD minus RA, which is equal to just subtracting that, and I'll do it like seemingly in my head. This should give me minus 960I, yes, and then I have 960 minus 240, so that will be no, RAD, yes, that will be plus 720 J, and then I have the 220, negative 220 and 0 there, so it will maintain minus 220K. See, we have it there. Okay, so with this I can find the magnitude of this one. So magnitude of AD, I'll say RAD, that is equal to the square root of this minus 960 squared plus 720 squared plus minus 220 squared. This is equal to 1220 point, okay, 1220. Yes, 1220. Next, it will be it's coming to flatly 1220. Strange, but that's fine. That's fine. So we've just gotten our RAD because the D is the AD is the one which we have been given the tension. So now get our unit vector in the direction of AD, which is just you divide the magnitude into all these. So I'll have um, mm, I'll have that's 960 divided by so I have 0.7869 I, okay, then plus we have 722 by the 0.5, is it? This is minus, sorry, 0.5901 6J, and then minus we have that divided by alpha A 0.1803K. Awesome. That's our unit vector. Okay. So then to get our TAD, we'll just multiply the magnitude of 305 multiplied by this TAD, which is by the UAD, sorry. And if we do this, you should have minus 240 I plus 180 J minus 55 K, all these in newtons. So this is our TAD. At least we are done with one, isn't it? Yes, we are done with one. Okay. Now in order to sum the forces in the Y and in the X, because we'll need to sum forces in the Y and in the X, so we'll need to express the other also TAC and all these others. We'll need to do those. What a burdensome work. Nevertheless, we'll do it. So let me just scroll up here a bit. Okay, and I'll change to maybe green. So I'm tired of the color I'm using. Okay, so I've already gotten I now need the position vector RAB, which is equal to RB minus RA, which is equal to from what I had before, my RB was just like 380K, and that's all it was. So with that the way it was, then I'll have minus 960 I minus 240 minus 240 J, and then I'll have plus 380k, isn't it? Right. And then you get the magnitude of RAB, which is equal to the square root of minus 960 squared plus minus 240 squared plus 380 squared. This will be equal to 1060 millimeters. So it seems, yes, millimeters. Awesome. So we've gotten the magnitude. So then the unit vector in the direction of AB will be equal to dividing this in there. And so we'll have for the first one we'll have 0.9057I, and then this is negative, and then minus 240 divided by 1060, and that's minus 0.2264 J, and then plus 380 divided by 1060, and you have 0.3584K, isn't it? Awesome. Then our TAB then will be equal to just that. Okay, it will be equal to our TAB, which we don't know, multiplied by the unit vector AB, which is this. Awesome. We'll do the same for we'll do the same for TAC. Okay, so we are saying that RAC is equal to RC minus RA, which is equal to if this will also be negative 960I, and then it will be minus 240J again minus 320K. Awesome. Finding the magnitude of RAC will be equal to that minus 960 squared, and then plus minus 240 squared, and then plus minus 320 squared, and this will be equal to 1040. This is 0 millimeters. Awesome. So then the unit vector in the direction of AC will be just dividing that, and since I've divided before, I have negative 0.9057I minus 0.2264 J minus, and then this one is 320. No, it won't be exactly the same. It won't be exact. One is I'm dividing with 1060. This one I'm dividing with 1040. Even though the answers will be very close, they won't be the same. So it will be 960 divided by 1040. No, this is minus 0.92308 I, and then minus, you have 240 divided by that 0.23077 J minus, so you have 0.30769. Okay, that's our unit vector. Awesome, very awesome. Okay, so then we see that our TAC as a vector will be just equal to the magnitude of TAC times the unit vector in the direction of AC. Okay, and we are not really going to solve it, but we know it is that. Okay, awesome. So we'll get back now to the equation we established on top there to say we need to sum all the forces and get 0. Awesome. So we'll sum the forces in the X, we'll sum the forces in the Y, we'll sum the forces in the Z. Okay. So I'll just probably reduce this. Hope we are able to see. Then move it so that I'm able to see everything. Nice. Then I'll work here. Change to black. Let's see now. I have my TAD. I have my I can actually get my TAB easily, and I can get my TAC easily. So summation of forces in the let's start with in the K direction or in the Z. So summation of forces in the Z, okay, is equal to, so summation of forces in the Z, I'll need the component of AC, and then so I'll have TAD, I have minus 55, and then TAB I have this will be plus 0.3584. This will be TAB. And then for TAC we'll have, actually it's minus, yes, for TAC we'll have minus 0.30769 TAC. Right, so that's what we have. We'll consider it as our equation 1. So EQ1. So summation of forces in the y will be also, notice that equation 1 has two unknowns, so we need another equation which will have two unknowns. So that's why I've used summation of forces in the y. So summation of forces in the y, I have my 180 there. By the way, this should be equal to 0 for equilibrium. So then even this one, you have 180. Then here I have minus 0.2264 TAB, and then minus 0. I don't understand why I have a small. Okay, let's try to see if we can write it here. 0.23077 TAC. Okay, TSC, that's TSC. Okay, so that should be equal to 0. Okay, so with these two simultaneous equations, we can actually solve for TAB and TSC. Okay, so here I recommend substitution method, and we are going to use from equation 1. This is equation 2. So make from equation 1, make make TAB subject. Okay, these things we know, isn't it? So TAB is equal to the 55 will cross the sign, it will become positive, it will be 55. What else will cross the sign? The minus 3 TSC will cross the sign also. So minus 0.307690 AC. Then all these will be multiplied by 1 over the coefficient of TAB, which is 0.3584. 0.3584. Sorry, I am really trying to. Okay, then I have a big board. Okay, 4, right? So if you do that, you have something like let's do 55 divided by 0.3584. Okay, so we have TAB is equal to 153.4598 minus when this 0.30769 TSC jumped, it also became positive, so it can't be minus here, it has to be plus. So this is plus, and so you have 0.30769 divided by 0.3584. Okay, so you have something like 0.8 5851, okay, and then multiplied by TSC. So this will substitute in equation 2. So we'll say substitute TAB in EQ2. Now this is something which probably we are very familiar with, so I don't think anybody can fail here. So we are saying that now we'll have we'll have 0 picking it up from here. We have 0. 180 will go that side, or this will go this side. Okay, so the positive one then. 0.2264, then brackets 153.4598 plus 0.85851 TAC, okay. Close that, and then plus the 180 has already jumped to the other side. That's why we are seeing this 23077 TSC is equal to 180. That's the equation we need to solve for TSC. And if you solve for TSC, you should get 341.709 newtons. That's your your TSC. And if you come and substitute it here in this equation we formed to get your TAB, like from here, find that your TAB will actually nicely also come out to be 446.7109 newtons. Okay, now that we have these two, this is a bit long. Okay, now that we have these two, we'll definitely need to go to the third equation now to get P now. So we'll get these two, we'll come with them here where we have summation of forces, isn't it, in the X. Okay, summation of forces in the X. Let's just do that. So from what I have, I'll have summation of forces in the X is equal to 0, which is equal to P, we'll start with P, minus 240 I for TAD minus 0.9, let's increase the pen a bit, 0.9 057. This is being multiplied by TAB, which is 446.709, and again again you'll find that it will be a minus. Let's see if we can utilize this space. Yes, minus for AC to be 0. It was 92308. 92308 multiplied by the 341.709. Okay, this should give us 0. So the rest which remains, it's just punching in the calculator and you get your answer. I would recommend that we be a little bit more careful, especially in punching the calculators and everything. But you find that if you are really done well, your P should be equal to 960 newtons. Okay, so that's the answer. Whew, this question was involving, but at least we have seen how to do it from A to Z. I know my writing is scruffy. I'm using my finger to write on my screen, but I hope you follow through. Okay, thank you.